Hey guys, welcome back to my new video. In this video, we'll be solving a GFG problem, post-order traversal. So basically, with the post-order traversal term, we'll get to know we have to traverse the tree in a specific order to get a sequence of the nodes. So a post-order means we'll be traversing from the downswise, and the approach will be first we'll be visiting the left, then right, and then we'll be approaching towards the root. Okay, now to understand it in a better way, just move it we just move it into towards an example, and we'll see the post order traversal of the tree. So coming to the example 1, so here it's given like this is a tree, it's given. So post order traversal, we have to traverse in a order, like first we have to visit the left, right, and then root. So coming when we'll be approaching this, okay, coming to this, then this node will be going left, right, and then root. So coming to the left, then come in this node, will be first going to the left. Okay, now coming to this, we'll first go to the left, so left is null, then we'll go to the right, right is null, then we'll process the root. So while coming to the root, we'll just print it. So 11 comes first. Now 11 we have done, the left part of this is done. Now we'll go to the right part. Now coming to this node, right part is 13. Okay, now coming in the node 13, we'll be just going to the left, right, and then root. Now for each node we'll be following this sequence. Okay, now coming to the left part of this 13 is null, right part is 13 null, then we'll go to the root. Okay, now 13 will get printed. Now coming to this node 10. Okay, now left part is traversed, right part is traversed. Coming to the root, it gets printed. Okay, so till here it has been processed. So the left part of this root 19, okay, it has been processed. Now moving to the right part of it, it's 8. Okay, again it has a sub left and right child as a null, so ultimately the 8 will get printed over here. And since this whole as a whole tree, the left has been processed, right has been processed, then we'll be moving to the root, that is 19. So 19 gets printed over here. Okay, now same with example 2. Now it's a short tree given with just 3 nodes. Now first we'll be moving towards the this node 11, then we'll be moving to the left and right. Okay, then root. So left part will be coming 15, then with the 15 again we'll be following the left right root formula. Okay, coming to the left part of it, then for this again left is null, right is null, again we'll be processing the root, that is 7. 7 gets printed. Now for this node 15, left has been processed, right is null, again we'll be moving to the root, that is 15. Okay, 15 gets printed. Now coming to this node 11, left is processed, right is null, coming to this root, that is 11. 11 gets printed. Now this approach, post order traversal, you can be performing in basically two ways, like recursive approach and iterative approach. So first I'll be explaining you the recursive approach, which will be as is, like it has been told to return the array list of integer. Okay, so first we'll be creating an array list of integer, we'll be naming his list and new array list. Okay, and ultimately we'll be returning this, list. Okay, after storing some value, so value will be stored with this user defined function post order. Okay, calculate, and we'll pass the root and the list. Okay, now we will be calling in order to store values to the list. Okay, that is the array list that we have declared. Okay, and it will be void and post order calculate will do, and note this will root, and this is a array list. it as a list. And yeah, first we'll check the corner condition. If my root is equal to null, then directly will return, else if we'll be going to the left, right, and then root. Okay, so processing the left first, post order, and we'll be processing the root dot left. Okay, and right, and then list dot add, it will be data, root dot data. Okay, now checking for its syntax error. Okay, post order. Okay, okay, left list we have to pass. Okay, we were missing the list over here. Got compiled and checking for all of the test cases. Now even this got compiled. Okay, now now this was the recursive approach that we have just seen. Now coming to the iterative approach. Okay, now how will we without using this recursion thing? Okay, how will we solving it? Now first, now if we are like using the iterative approach, then usually in all other traversal we use a stack, but in this post order traversal we will be using two stack approach. Okay, now first we'll be creating a array list that we have to return ultimately, and we have to return this list, and we'll be declaring stack of node is one stack. Now what we are doing in this is we'll be taking two stack. Okay, and then first we will be pushing the nodes, like 19 will push it, and if it has a left and right child, then we'll push the 10 and 9 over there. And since we have already processed the left and right child of the 19, so again will 19 will be popping out from the stack 1 and will pushing out to the stack 2. Okay, now in that way, then we'll be pushing out the uh, eighth one, like it's eighth one, like first 10th is pushed, then 8, so top is 8. 8 one will be pushed out of the stack 1, and its left and the right child will be pushed into the stack 1. Okay, so it's null. Okay, so nothing will be pushed into the stack 1, and stack 2 top will be 8. Okay, first 19 and then 8. Stack 1 top is still 10, and it has 11 and 13 as its children. Okay, so 10th will be pop out from the stack 1 and will be pushed on to the stack 2, and 11 and 13 will be pushed into the stack 1. Then 13 will be pushed out and placed at the top, and then 11 will be pushed out of the stack 1 and will be placed into the stack 2. So stack 2, you can see like the order in which it will be stored will be 13 11, 13 11, then it will be 10 8 and 19, 10 8 and 19. So it will be like 13 11, 11 and 13. Why it says opposite? Why is it opposite? 11 will be printed and then 13. So 13 will be popped out first. Okay, okay, here it is. Okay, it has a null value, that's why. Okay, and then we'll be processing the left part first, and then we'll be processing the right part. Okay, now first the 11 will be popped out. Okay, and then we'll be pushing out from the stack 2. Okay, then we'll be storing it in some variable. Okay, so first 11 will be pushed out, and then 13, then it will be 10, 8, and then 19. Okay, so in this order it will be pushed out from the stack, and we'll store it in a list. That is, we have used the array list as a data structure. Okay, so first s1 dot push the first element root. Okay, and while my s1 is not empty, till there it will, and root is equal to s1 dot pop. Okay, after popping, just s2 dot push root. Okay, and we'll check if it has a left and right child. If root dot left it's not equal to null, now we'll push it to the stack 1. This one dot push root dot left. Okay, while if root dot right is not equal to null, then s2 dot push root dot right. Okay, and yeah, now till here all the elements will be pushed into the stack 2, and s1 will be empty when it will come out of this while. Now we will be just pushing out the element from s2, and we will be storing into the stack, not stack, it will be the array list. Okay, so while my s2 is not empty, while my s2 is not empty, so this dot add, and we'll just check it if it's correct. Okay, compilation error, pop. Okay, pop dot value or data. Okay, data, because it's integer type list, and the stack we are storing nodes. Okay, yeah, it's correct. Now checking for all other test cases. Oh, why is it? Okay, then s1, s2 we are taking. Okay, array list stack 1, stack 2. Okay, if root, okay, my corner condition I should check first. Okay, before this stack we should check like a corner condition. If my root it's equal to null, okay, then just return the empty list. Okay, here itself you should return the empty list. Then s1 dot push root while s1 is not empty. Okay, root is s1 dot pop. Okay, s2 dot add push root. Okay, not empty, then push left, then push right. Okay, if s2 is not empty, then list dot add value. Okay, list dot add is2 dot pop dot data. Okay, checking for all other test cases. Why is it not